What did I want to do? Okay, all right, it's working. Well, hi everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your virtual star party for July 7th, 2013, the 3 days after Independence Day edition, I guess. Um, Tonight we are going to hook up a bunch of telescopes, and by a bunch I mean two, into a live Google Plus Hangout and show you some stuff that's happening in the night sky right now. Lots of bad weather and lots of sort of busy summer plans for a lot of our people. So it's just going to be just us tonight. So joining us this week, I'm going to sort of start with the telescopes. We've got Gary Gonnella, who's in Los Angeles, and we've got Stuart Foreman, who's in the San Francisco area, so West Coast. And
Hi, everybody.
Stuart is showing us this globular star cluster right now. And then joining us for sort of additional brain power, we've got Dr. Thad Szabo.
Good evening.
And we've got Cory Schmitz, who is got bad weather, but was going to share some crazy images and regale us with some stories that he just captured a bunch of images. So, all right. So let's just start with this image that we're looking at right now. Stuart, what are we seeing?
This is M13. It's the Great Cluster in Hercules. This is a 60-second exposure at ISO 800 with a Canon XSI camera, and this is non-cropped, slightly stretched in noise reduction, but this is sort of as you see it in the camera.
So,
oh, go ahead.
okay, yeah. So I mean, globular clusters are essentially left over from when the galaxy formed, meaning that the stars that are in there are about 13 billion years old. This is the second largest one that's visible to us with that accompanies our own galaxy, and the largest one easily visible from the northern hemisphere. And if you look at kind of SETI activities, there was a signal that was sent at this globular cluster as from the Arecibo radio dish in an attempt to say, to try and make contact. I'm not sure that was the wisest target, because it's very unlikely that there's any life there. But that's where they sent it.
So they tried to send communications out to try and make contact with folks in the cluster.
Yeah, there was right. They kind of fired a burst, and I forget what exactly was in the message. I mean, we could possibly ask Sandy, I guess, the next
right
hangout, but the weekly space hangout. But yeah, I mean, essentially, a globular cluster isn't really the place you want to do that, though. The stars are old, and they don't tend to be very metal-rich. And one thing that we know is necessary for at least life here on Earth is having this abundance of elements heavier than helium. If you have a bunch of old stars, like in a globular cluster, it's going to be mostly just hydrogen and helium that make up the stars. Now, as some of them die, it could possibly create some carbon and oxygen, but you won't have quite the rich array of elements that would be typical in, say, the part of the galaxy where our sun resides.
So just to let people know, you can comment, you can talk to us, as it were. You can make any requests if you want. If you know some objects that are up in the night sky, usually we have some new objects that we never even occurred to us to look at when people make requests. So it's awesome. So the ways that you can do that, you can make a comment over on the event page if you're watching this on Google Plus, or in my stream if you're watching this that way, or you can make a comment over on YouTube. You can also use Twitter, although it doesn't seem to be working very well. So the safest place, we always say, is over on YouTube. So if you're watching this, anywhere, just click on it to watch it on YouTube, and then you can make your comment there. Yeah. So I'm going to move on to the object that Gary is showing now. Chris, can you hear us? No, this is Chris. Chris is going to join us. He's got his telescope too, but he's having some technical problems. So we'll see if he's able to hear us. And if not, then he will watch us. So, Gary, what have we got?
We have M16, the Eagle Nebula, and this is a 60-second exposure with no binning. So I can.
You know what we want to see, Gary? Like just make it happen.
You want to see the pillars of creation.
We do.
And this is 60 seconds. And there it is right there.
Nice.
That's the famous Hubble part. There's the whole picture, so that's right in this area here.
Looks about the same, I think.
Is Hubble?
Yeah. It's about the same as Hubble. A little better, I think.
Mine's got better color.
Yeah, but I might be remembering it wrong.
Yeah, you never know.
But I always wonder, like, the pillars are such a strange shape. They look like a rocket kind of blasting off through this nebula. What's really going on there, Thad? Well,
I mean, any time that you have material that's kind of collapsing under gravity, you also have shock waves that have gone through here repeatedly from nearby supernovae going off. So, the shape, if you look across most nebulae, you're going to see some kind of twisted forms in here. The pillars, again, if you look closely, for instance, at the Hubble pictures, you can see inside you'll see a pillar, and then you'll see a little protuberance off of one side of it. At the end of that protuberance is where a star is forming. Once fusion kicks in, it kind of is able to shed that dust away then. So yeah, I mean, the variety of possible initial conditions in a star-forming region like this, you can get all kinds of weird shapes going on. So, yeah, to try and rewind time and figure out, well, how exactly did it get this shape? That's an extremely difficult problem to try to do computationally, and especially from observations, because essentially, I mean, it's very hard to get any kind of 3D feel here. You get the idea of, okay, well, there's this dark gas standing out against this bright background, so I mean, it's a little bit of a 3D feel. But I mean, anything that you do in space where you're trying to, image something and also get a feel for the distance is very difficult to do. So yeah, trying to rewind, okay, well, how did it end up looking this way instead of like a smiley face or whatever else? That's a non-trivial, almost a not possible problem at this point. So
now I'm hearing some reports, and I'm actually sort of able to confirm this. I guess I'll have to click on me for a second here. That nobody is able to see the film strip at the bottom of the presentation. So we're just seeing whatever is the thing that I'm clicking on, and we're not actually seeing the various objects, which is, I don't know if people are watching this. Is anyone seeing anything different? That's really strange. So
I'm watching it, and there's no film strip on there.
Yeah. Okay. All right. Well, I'm gonna have to tell Google that there's a bit of a bug. So I apologize to everyone. Normally you see this little film strip down at the bottom, but we're not getting it. So I'm gonna go back. So you're just gonna have to hear these voices. I will try to sort of switch back and forth when people are talking, but no, this is unfortunate. Okay. Back to Gary's image here. So
okay.
Yeah. So I mean, this is the full kind of zoomed out view of it, and the field of view that Gary has here. I mean, you could fit about 5 full moons across there from one side to the other to give some idea of how big this thing looks in the sky. That entire bright region there. That's about the size of the full moon.
Connection is like really bad for some reason. I don't understand why the connection is so damn bad.
Oh, well, we'll try again. We'll try again next week, Chris. Yeah, we'll do some tests over the week, and we'll figure it out. So okay, so sorry to be like doing troubleshooting with people, but while I had it on me, I could see the film strip. But then when I click back on Gary's, it goes away. So I don't know if people can confirm that that's what they're seeing. All right, well, we're gonna go move over to Cory now and see if and sort of hear a report on Cory's latest little trip and his the images that he captured. So Cory, what have you got?
I actually got the Eagle Nebula here. I imaged the Eagle Nebula 2 days ago.
All right. Yeah, go ahead.
From my dark sky location that I went to. I had to drive about 2 hours away from my house, and this is what I came up with for one of the images. Using an 80 millimeter APO telescope and a DSLR, and this is a 5-minute exposure.
Yeah.
Unedited, straight from the camera, so it's just as if I was there. This is what it looked like for me, and yeah, so.
Is this your camera that's modified to pick up more,
Yes.
more red? It
Yeah.
has the red filter taken out?
Right.
Okay.
It's got the IR filter removed and replaced with a Botter IR UV cut filter. So.
Yeah, great detail in this. So.
Yeah, and that's zoomed in quite a bit. My field of view is this is the full field of view of the scope. So.
This is so. I apologize to be sort of trying to debug right now, but now that's back on me. I think people see the film strip, and then when I click on Cory, for example, the film strip goes away. So I don't know what to say. Some people prefer it that way. They just like space, but no one can even see this, right? You can't even see me going space. I just did a hand gesture and nobody sees it. So this is enraging. I must remain professional. Okay, so a couple of questions here while we're sort of looking at this. Bernie Eliada asks, does the image display even larger in the infrared? So if you can see it in infrared, would you see more nebula?
Wasn't this technically IR? I mean, that's what hydrogen alpha is in the near infrared spectrum, right?
Well, hydrogen alpha is at a wavelength of 656 nanometers, which is still technically red. The cutoff between red and infrared is 700 nanometers. So let's see. So no, this still falls within the range of red. The thing where you get more infrared radiation is if you have dust, if you have let's see, if you have other material extending outside of the nebula that's cooler, it could possibly glow in the infrared. So answer to your question, I mean, yeah, I mean you could probably see a little bit more out from the infrared. But it's not. There's I'm having trouble thinking of potential cases where you see a drastically different picture in the near infrared compared with visible light. So it's usually usually one traces the other pretty well, because most of the stuff that's out there that makes up any one of these is hydrogen, and hydrogen has these lines that show up strongly at about 656 nanometers, about 480 nanometers, 450, 430. So visible light lines, and against the most common transition in using visible light is that 656 nanometers, which is H alpha. So yeah, so really, okay, so I guess I did answer it. That yeah, you wouldn't really see that much more if you did look with infrared.
So I figured out how this is happening. So whenever anyone has they're doing a screen share, then it shows it as full screen, and when it's a camera on them, then they get the film strip. So
change something.
So so they've implemented some new technology. Okay, all right. Well, I'm gonna have to act more like a cameraman, I guess. So let's see. So I'm gonna move to Stuart's image now, and then maybe Cory, you can cue something else up. So this is now Stuart's image.
And this is the Ring Nebula, and this is full color, non-modified camera. Cropped quite significantly because the Ring Nebula in my field of view is pretty small, but this is a 2-minute exposure at ISO, I think it was 800 that he took this. And you can see some nice color in it. You can't really see the central star because it's only well, maybe you can. I can in my view. It's a 2-minute exposure, and you see some different colors in the various stars around it.
Now,
Thad, you're up.
well, actually, Stuart, is there any way that you can kind of zoom in a bit on it and give us a bit of a bigger view? There we go.
Okay.
There, how's that?
That looks great.
It's a little fuzzy, obviously, but it's because it's cropped, uncropped. But and you're seeing some debayering, some bayering matrix noise in there, but it's still pretty good for a 2-minute shot.
It looks terrific. Stop beating yourself up.
So again, you get a little bit of red on the outside, and that's hydrogen, and then the greenish blue glow in the middle is ionized oxygen. So what you're seeing is kind of the heavier elements don't move out as far. Also, they're kind of coming from later on in the evolution of the white dwarf in the middle's life, so they're kind of farther in. The hydrogen would have been puffed out earlier, and so that's much farther away from the central star there. And of course, the star that you can see here is not actually the white dwarf at the center of this. I've been at numerous star parties where I've been like, oh yeah, I can see the white dwarf, and they're like,
right. There's the white dwarf there in the middle.
That's not it. It's another star that's between us and the Ring Nebula, faint star, and kind of tricks people into thinking that they can see the white dwarf. The white dwarf is much fainter.
It's actually in front of the nebula.
I think so. I mean, if it was behind, it would be obscured by the dust and gas in the nebula. It would have to be exceptionally bright in order to get through that way. Yeah, I don't know if anybody's done any kind of spectroscopy on it. You wouldn't be able to do parallax to measure the distance to it. If it was nearby, if it was closer to us than the nebula, there's a chance you could use parallax to measure the distance. If it's farther away, well, okay, then you've got to subtract out the absorption lines and emission lines from the nebula to figure out, okay, well, what's the nebula, what's coming from that star. Kind of a tricky problem, and then spectroscopic parallax is not nearly as good as geometric parallax for determining distances. So
now I just changed a setting in the cameraman functionality in the Hangout, which is apparently supposed to do the opposite of what the option says it does. So I don't know if it's working yet. Okay, all right. So we can find. I mean, I always mention this. This is my favorite object. You can find the Ring Nebula. You just look up, the 3 bright stars in the sky. It's the Summer Triangle. You can see Vega right overhead, and often, for me anyway, in Canada. And then you can see these sort of. It looks like a fish almost. And then sort of in the very end of the. Yeah, that is showing us here. Once you do the shape, right? So
okay, well,
Vega.
It's a good parallelogram. I mean, there's Vega, and then there's a parallelogram off to the side of Vega. It's a little bit to the east of Vega. And if you look at the side of the parallelogram, the short side that's farthest from Vega, the Ring Nebula is almost dead center in between those 2 stars. So it's an easy find. If you're trying to learn how to find deep sky objects, this is a great first one. It's got a high surface brightness, so I can see it even easily from here in LA. And yeah, it's so well positioned between stars that allow you to find it that it's a good one for if you want to try your first shot at these things that are way beyond our solar system. This is a very good first object to try for.
Yeah, absolutely. It is just a treat. Even on a small telescope, you can see just a little ring, little donut.
Like a little smoke ring in the sky.
Yeah, it's great. All right, I'm going to move to Gary's view here.
Okay, we have...
I don't know what it is. Oh, hold on. Let me think. The Wizard?
No, it's M17, the Swan.
It's the Swan. Okay,
Swan,
all right.
Or the Omega Nebula, or the Lobster Nebula. I think in the orientation right here, I see maybe like a 1-clawed lobster. But yeah, this is another bright region of hydrogen. It's getting flooded with radiation from a very hot, new, young, massive star, and causing the hydrogen to essentially fluoresce, and that's what we're seeing.
And I love all the little tendrils that it can have.
Yeah. And how long of an exposure is this?
That's 1 minute and no binning.
That's amazing how much you can get on this with just 1 minute. And
in fact, it's too much here.
Right. And again, this is another pretty good object to go look for, because that area that's blown out, that's too bright, is pretty easy to pick up in a scope visually. Now that the extra material that extends farther away from that, you're never going to be able to see that with the naked eye, but a good photograph, brings it out really well.
That's terrific. All right.
So Cory's
So
got his version.
yeah, I'm gonna go over to Cory's version. This is great. Cory is just following along. He's taking all these same pictures.
Yeah, I just heard him say I had the Triffid Nebula queued up, but then Gary showed the M17, so I was like, oh well, I'll do mine.
Yeah.
So this was a 5-minute exposure. You can see it in the top of the file, and they make all the details. It's a 5-minute ISO 800 exposure, straight from the camera, and yeah, I mean, you can see the detail in the inside. That was kind of nice.
Oh.
So.
Yeah, in processing,
I can zoom in a little bit more.
The thing is, with what Gary's doing is essentially kind of just taking it straight from the scope and giving us an image we can see. With processing, you can say, okay, don't bring up the central region quite as much. All right, let's go in and bring up the levels in.
This is unprocessed. This is completely unprocessed.
Yeah, these are he warned me. I'm sorry, I should have told you guys. He warned me. He's like, these are going to be my unprocessed images. So
yeah, these are raw. These are raw straight off the camera. I haven't had time to do anything with them because I was out for 2 nights in a row, and I've got 100 minutes total of all the targets that I shot, including this one. And this is one exposure that hasn't been stacked or anything. So no adjustments.
I'm kind of dumbfounded now. That's amazing.
Well, this telescope.
If you want, you can have the data and you can play with it if you want. But yeah, if
there's other astronomers joining us, the astronomers will often do this. They'll share their raw data over on either the space community or the photography community, astrophotography community, and then just take turns processing each other's photographs to sort of see what they can pull out of it. There's some great tutorials if you kind of dig back into the catalog of in the communities of sort of how to do some of the processing that the astronomers do. So that is really cool.
Yeah. Yeah.
So then to show the field of view of my scope there's the whole image right there. So
one thing that really stands out with this nebula too are the idea of dark nebulae, that you have regions where the hydrogen's getting hit with this incredibly intense ultraviolet radiation, but then you have regions where the amount of gas and dust is so dense it just blocks the field of view of everything around it. And then kind of near the neck of the swan or in between the claw of the lobster up here, you have this one of the darkest dark nebulae regions I think I've ever I've seen in the sky. Kind of over to the right there. One thing you can do is kind of check what values go with a certain pixel with what amount of light. This is just ridiculously dark in there. So very dense, good star formation region.
All right, I'm going to move over to Stuart's view again, and I apologize again for the weirdness. Okay, so I've got a couple of questions here too. Let's see. BTL743 wants to know, what does binning mean? So
binning is essentially if you look at kind of a raw photograph, then each pixel represents how much light has fallen on that pixel. What binning does is say, okay, no, we're gonna take a square of 2 pixels by 2 pixels and combine all of the light into just 1 pixel. Or we can do it 3 by 3. We can do 3 by 3, 3 pixel by 3 pixel squares. So what it allows you to do is take much shorter exposures, but they don't quite have as much detail. So I mean, they're very good. It's a very good practice for people with really large fields of view, and then here for the virtual star party where we're trying to get images out quickly, because it allows for much faster gathering of light. 2 by 2 binning lets you gather an image 4 times faster. 3 by 3 binning lets you gather an image 9 times faster. So,
that made total sense. And Kevin Franklin says that apparently that central star in the Helix Nebula, it's the same deal, that it's not really there.
It's faking us out.
Yeah, exactly. And speaking of, what have we got, Stuart?
This is the Dumbbell Nebula.
Oh, the Dumbbell Nebula. Oh. I see a central star.
Yeah,
Probably
and
the same thing.
this nebula has always been one of my favorites because it just has a ton of color in it. This was a 3-minute exposure at ISO 400. And you're not, it's the very outside edges of it are supposed to be a little redder, but since my camera's non-modified, you don't quite see it, but you can see the blue in it really nicely.
And yeah, I think here we do get the central star. I mean, the images of this that I've shot, you can see kind of a yellowish or reddish tinge to most of the stars around there, but the one in the center glows a very white or blue-white, and that's characteristic of the heat of a white dwarf star that's left over when a star like our sun reaches the end of its life. But again, here the blue is bluish green color around the center. There is ionized oxygen, so much heavier element produced kind of at the end of a star's life.
And then we've got what's cool is Cory is got his version of it as well. Again,
Yeah.
raw, Cory.
Yeah, this is raw. I didn't even actually image this one at the dark sky for real. This is just one exposure I took to see what the difference was between my home imaging location and the dark sky. And it's actually such a bright object, I didn't bother doing it at in the dark skies. I just decided to stick and do it at home. But this is a single 5-minute exposure. Yeah, raw. So.
Wayne W says, try the Saturn Nebula for colors. So, can you see this? Is the Saturn Nebula up right now?
No, I think it's in Aquarius, and so you would need to get up at some,
Yeah.
you need to be out imaging at about 2 a.m. I think to be able to have a shot at it.
And then Chris.
That's early for Cory.
And then Chris Elliott has a view of it as well. But this is not live, Chris.
No, it's not.
Yeah. Oh, we're
That
getting
was
some,
taken. Yeah, that was
some
taken
echo
at
from
Cherry
you.
Springs back in May.
Yeah, we're getting some echo from you, so you need to put some headphones on. I'm gonna have to mute you.
Okay, not a problem.
Okay, I'm gonna go to Gary's view.
This is...
Oh, right, this is the Borg Nebula,
Yes, that's it. You got it. M8, this is Lagoon.
the Lagoon Nebula. Yeah.
Tried to get this last week, but it hadn't quite cleared the trees yet. But I love the little, as Slarty Bartfast would say, the fiddly bits in this one.
Yeah, especially, I mean, you get these tendrils of the hydrogen gas, but even a little bit toward the lower right corner of your frame right now, that dark little knot there, that's a star forming in there.
Neat.
That tight little knot in there, that is where that's where a star is forming. And again, this is another pretty good object to look for if you're just trying to figure out how to look for deep sky images. If you look at the constellation Sagittarius as a teapot, this is just above the spout of the teapot. It's kind of, if you imagine the Milky Way as steam kind of rising out of the teapot, this is a very bright knot in that steam. If you turn a telescope or binoculars to it, this is what you will see.
Just really, can you zoom back out again, Gary? It really just looks like the Borg, or like, I don't know, Homer Simpson, like
Well, yeah.
like a
Is the
chimpanzee.
mouth, the nose, and
Yeah.
a Homer
Right.
Simpson forehead.
Yeah.
And this, I mean, this
That's
is
what
kind
I'm
of rotated
thinking.
90 degrees from how most people usually show it. But I mean, yeah, it's amazing the pareidolia you can get out with this kind of thing here. So, other interesting little factoid about this: that this nebula is almost exactly where the sun is on the winter solstice on December 21st. This nebula lies very close to, happens to lie very close to the ecliptic, and so the sun is practically just right here on December 21st.
But much closer.
You could, yeah, give it a couple thousand light years closer to the sun rather than to the Lagoon Nebula.
And Cory, have you got one as well? No, you've got the.
I have a lagoon
The lagoon.
from a couple of weeks ago.
I'm not seeing it. I'm not seeing the
No,
same thing.
this is the Triffid.
That's the
This is
Triffid. Yeah.
Yeah, this is M8. I can pull up a lagoon from a couple of weeks ago if you'd like to
Sure.
compare. So I'll find that quick.
Sure, and I'm going to move over to Stuart's view because I'm seeing he's got something new.
Yep, this is called the Double Double, and this is quite zoomed in. It's Epsilon Lyra, and it's kind of near the ring. Actually, not kind of near. It's very near the Ring Nebula, and it's kind of just on the opposite side of it. And if you look at it under very small magnification, it just looks like a double star, but if you zoom it in, you see these two double stars, and so that's why they call it the Double Double. And I absolutely love this because it's one of my favorites for star parties, and it's just so delicate and very cute.
And again, there's all these neat little geometric forms in Lyra. Like I said, there's the parallelogram, and the ring is between, to the two stars on one of the short sides of the parallelogram. If you go in the other direction, you get Vega as part of a close to equilateral triangle, and Epsilon Lyrae is one of the other vertices of that equilateral triangle in the other part of Lyra. So
that's great. Now, Cory, don't tell me you've also got this queued up for us. No, I think he's got his.
Wow.
Yeah, he's got his view of the lagoon.
So it's the lagoon plus the Triffid Nebula. I mean, this is an enormous field of view, able to get both of these things in here. So, and showing kind of how close together they are in the sky. Not at all close together in space, but but in the sky they kind of sit kind of right on top of each other. So the Lagoon Nebula is to the south. The Triffid Nebula is to the north, but again, all fairly close together in the sky, close enough for Cory with his enormous field of view there with this setup to be able to get both of them together. So, very nice.
That's fantastic. Nice work.
It's interesting that I can get like such a good image out of an 80mm aperture. It's not, it's relatively slow, isn't it? Excuse me.
To give some idea
7.5.
So to give some idea what Cory's talking about, I mean, this is like the bottom of a DVD case. The opening to his telescope is smaller than this, and he's able to get these kind of images with it.
Yeah.
So it's not always all about the bigger the scope, the better the image. I mean, if you have good tracking and if you have the right photo equipment. And good dark skies. I mean, dark skies make such a huge difference because I mean,
this was from home actually. So this wasn't in. This is in a border orange, yellow border.
But you did get a chance to process it, right?
No, this is a raw.
Another raw image. Oh
yeah. So I mean, you get some idea of the background, but still, that whole border yellow or orange. So I mean, there's a scale for how much light pollution interference you have. If you're where I am in Long Beach, it's white. It means you are not going to see any deep sky objects. It goes from white to red to orange to yellow. I usually image from like an orange or yellow area, and you can see the Milky Way. You can see stars down to about magnitude 5.5, close to 6. But when you go to process your images, there's this strong background to them. Green, the edges of like Joshua Tree are kind of green. You get deep into Joshua Tree, it's dark, it's blue, and then the absolute faintest background light on the Bortle scale is there's dark gray and then there's black. I've only ever been to 2 black sky sites in my life, Death Valley and then in Botswana, and it's crazy some of the stuff that just hides from you that then comes out in plain view when the sky is that dark. Zodiacal light is like a spotlight if you're under someplace that is that dark and has that little interference from man-made light. So there's
I can.
Go ahead. Sorry.
I haven't been to the desert, but I was at a black sky site, which is luckily only 2 hours from my house, and it's the only place, like, I don't know, in the central U.S. that I've seen that's still black, according to the light pollution map that I've seen. And I don't know, it was incredible, even in the northern hemisphere, to see that.
Yeah, I'm really lucky. I've got. I'm actually headed tomorrow, actually, to my childhood home, which is Hornby Island. It's this little Gulf island off the coast of Vancouver Island, and I'll be there taking the kids there, and it's just pristine black dark skies. It's just unbelievable. So I'm going to take all my gear and try and do some. I'm going to take that 14mm, Cory. So I'm going to take some nice dark sky Milky Way stuff. So.
Good.
You'll be proud of me.
Sounds good.
Focus hard. Spend a lot of time focusing.
Yeah,
seriously.
I will. Well, because I mean, it's all manual, right? So
Yes.
yeah, totally.
So, but yeah, I mean, if you're on the East Coast, I'm not even sure where you can get to a Bortle black sky site. I mean, maybe I think Mike Rector is in northern New York. There might be something of that nature around there. But really, I mean, you've got to be out west or in the central part of the country. And out west, I don't mean where I am, because I mean, you know, I'm in this megalopolis of 12 million people. Where forget it, right? You're not going to be able to see anything. But if I drive out to the Mojave Desert, I can get to a black sky site in about 3 hours. So at some point this summer, I'll have to get out there and do some more imaging.
And we always remind people, set something up for the Perseids. It's it's only a month away-ish, and take a couple of days and go out and enjoy the Perseids. Camp out with your friends and your family, and it's such a great time.
And people always ask, what should I do to bring? What should I bring to watch a meteor shower? Bring a lawn chair.
Bring a lawn chair, yeah.
Bring a chaise lounge. Bring a blanket to put on the ground, and just
a warm drink.
Yep, and just something where you can just stare up and see as much of the sky at once as possible. That's how you watch a meteor shower. Yeah.
Okay, so Stuart has put up M51.
Correct. This is M51. It's this was a 2-minute, I believe. Slightly stretched in Photoshop just to sort of bring out a little bit of the color, and with a noise reduction filter put in. But you can see some of the nice spirals in that.
Can you embiggen it?
Indeed.
Now we're cooking.
How's that?
Nah, I like that. That I like. Tom Nath says, you guys need to come out here to Central Oregon, so he's invited us to visit him. Done. When can we come, Tom? We'll be there shortly. Actually, we're going to need to come to your house for the solar eclipse.
Yes.
Yes.
Yeah. Or not his house, because I think he's west of the Cascades, but it's getting out east of the Cascades where you really want to be for the eclipse.
Well, Central Oregon is east of the Cascades, right?
Yeah, that's true.
Yeah. BTL 743 says, I'm sorry when I hear Joshua Tree, I think of you too.
The cover photo for that was actually not shot in Joshua Tree. I've been to the Joshua Tree. Well, it's on the ground now. It's dead and fallen over. Sorry, U2 fans. But it is not actually in Joshua Tree National Park.
We got a request for Alberio in color. Oh, Stuart, is Alberio
on it?
Right? All right. Stuart, that's like one of Stuart's favorites. So you don't have to really ask him twice to go and bring that up. M51 interacting galaxy, little satellite galaxy going on there.
Yeah, so I mean, there's so it's M51 and NGC 5195 is the kind of brighter nucleus galaxy that's off to the right there, and kind of pulling a streamer of material off of the main spiral galaxy. This also shows up in the ARP catalog. The ARP catalog is a catalog of peculiar and interacting galaxies, and so this object, because there is the interaction between the two galaxies, shows up in that catalog as well.
Ronald Minch says, leave your children, more room for gear, if you're going to go see a meteor shower. Well, yes, that is true, technically, more room for gear. But the kids often enjoy it, so, who are we to leave them behind? That's great. I'm going to move to Gary's view. He's been...
Everybody was doing M27 just as I was shooting this one, so I thought I'd bring it up. This is M27 and hydrogen alpha. Again, a 1 minute at no binning.
I like your no binning.
It depends on what I'm looking at.
Yeah, I guess so.
Mm-hmm. But
yeah,
got another one queued up. So.
Oh, great. Okay. All right.
And I got M101.
Do you now? Okay. All right. Well, I'm going to see what Chris has brought up. So Chris has got Alberio, but this isn't live, Chris, is it?
Right. It's cloudy skies here, so I don't have anything. I just have pictures from the last month.
There you go. So that was taken. Yeah. So just to be clear, this is the first time joining us. So just to be clear, we try to avoid the the astro photos, but we try to make a real distinction between what's live. This is great though, because your image has got like this big when it was taken, and that is not today. So I think we're all right. But
if I was out, if it wasn't as cloudy, I definitely would be outside taking some live shots. But it's not nice here in New York.
and so, like, where is your nearest dark skies in New York? We were just talking about this.
The nearest from here is about 3 hours out in Cherry Springs, Pennsylvania. It's near Coudersport. And that's gray. That's not black, but it's gray on the Bortle scale.
So you can see the Milky Way there?
Correct.
Yeah. So, like, my backyard is probably what you guys would consider to be gray. And then, although I think it's yellow. You know that dark sky,
Clear dark sky?
Yeah. So I'm in a yellow zone, and then 5 minutes away from me, it's dark.
Yeah, I think where I grew up technically would have been maybe orange, and I could see the Milky Way in the summer from my house. I grew up, about 10 or 15 miles north of Bethlehem and Allentown, Pennsylvania. But yeah, Coudersport out there, there's central Pennsylvania. There's like Philly and Allentown and Scranton on the east, and Pittsburgh and Erie on the west, and like nothing in the middle of northern Pennsylvania there. So yeah, a lot of good dark skies in central PA.
All right, well, I'll move to Stuart's view here before he brings us the Albireo. But and what was that?
This is M101.
101, yeah.
And it's a face on Spiral Galaxy. Actually, this is the first time I've ever imaged it, which is kind of cool.
Okay.
It always looks so lopsided to me.
Yeah, I mean, the arms do stretch out much farther on one side than the other. There's a much thicker, portion of the disc of the spiral structure on one side than the other. But that one arm that sticks up to the top of this view, you can see some emission nebulae in that arm. There's some little bright knots in that part of the picture, and that would be like if you were looking at our galaxy from the outside, and you could see like the Lagoon Nebula or something like that, or the Swan Nebula, the Eagle Nebula. What you're seeing when you look at M101 and you see that those little knots in the upper portion of that spiral arm, those are emission nebulae that we can see from here about 20 million light years away.
That's great. All right, I'm going to move to Gary's view.
This is the Crescent Nebula in Cygnus.
Oh, that's great.
So this is what's called a Wolf-Rayet star. So the star in the middle there is enormously huge, enormously bright, enormously luminous. When it dies, it will become a supernova. But there's a lower limit for how big something has to be to start nuclear fusion. There's also an upper limit to how big a star can be. If it's above that upper limit, it becomes unstable and starts puffing out its outer layers. And so that's what's happened here, is that kind of crescent of gas that's off of this thing is the outer layers of this star that have been blasted off into space because the thing produces too much energy too quickly. And so it's kind of puffed out its outer layers and is now illuminating them. And so when this thing does when it does die, you'll see an extra star in Cygnus the Swan that glows much brighter than anything else around there. But for now, I mean, just extremely hot, bright star in the middle, and it's so enormous that it's puffed off its outer layers to view here as the Crescent Nebula.
Tom just said thanks for the Albireo shot, but Tom, we're not done with you yet here. So here's Stuart's view.
Yep. This is a 15-second shot. I kept it really short because I found that with Albireo, if I go much longer than that, excuse me, I lose some of the color. But you can, so that's why it's so black and there's not a lot of detail, but you can clearly see the blue and gold on it.
Well, so I'm just gonna switch quickly over to Cory's view because he's got it as well, and he let them. And I think his view it shows exactly what you're talking about. So you can see in his picture, you've lost that color, but and they're a lot brighter now, and you're getting those spikes, right?
Yeah, this is from last week's Star Party actually. So I made a diffraction spike mask, if you want to call it that, for my refractor, specifically for star targets like this, and it's just two pieces of wire making a crosshair. across the objective of the lens, and so that I can get diffraction spikes if I want them for art purposes.
Oh,
So,
art purposes.
right. And so I shot Alberio just for fun because it's a nice one, and you can see the color if you look at around the.
I can see some little diffraction spikes around some of the other stars in the image too. Like if you look over on the left-hand side, you have some dimmer stars, and you're still getting some spikes there.
Right, right. So and then some of the color shows in this pair.
Yeah.
Still does show in the diffraction spikes themselves. I've noticed. So
I'm gonna go back to Stuart's view here, and see the.
And so this kind of washing out of color is kind of a limitation of the way cameras work. You have an array of pixels. Essentially, when light hits a pixel, it will register with sending out an electron that gets stored at the edge of the array, and then some other process comes by and sweeps through and says, okay, well, I collected this many electrons from this pixel and this many from this pixel. And so the thing is, as you hit it with more light, then the number of electrons just fills up until it gets to a maximum value. Well, if you get the maximum value in red, in green, and blue, the whole thing just looks white at that point. So this is what's going on with the colors if you just expose for too long, is that you fill up the red, green, and blue bins entirely. At that point, you've just created something that has that's just white.
Now, the way it looks in this image, though, I mean, one, is it an actual binary star?
We don't know.
Nobody knows.
Nobody knows.
If it is, they have an enormous orbital period, like greater than, I think I've seen some estimates putting it at about 100,000 years for an orbital period. Or they could be what's called a visual double, where it just happens to be two stars and one is closer than the other. But because they lie along a line, they look like they're together in the sky, even though one is much farther away than the other one. So, so the jury's out on this one. I guess if we can watch it for a couple more 100 years, then we'll know for sure.
And also in this image, it looks like we're seeing like the big disks of the star, but we're not seeing the disks of the star. They're just points.
No, they're points, and it kind of bleeds out into the other pixels. And
yeah.
the other thing is,
I'm sorry. This is just because it's cropped and zoomed, and exactly. So it's not supposed to be like this. But with bright stars, this is just what happens.
It looks great. I think it looks super cool. So I think don't worry about it. Don't beat yourself up so much, Stuart.
No self-beating over here. No.
All right, no flagellation. Okay, all right. I'm gonna go to Gary's view.
And if you don't know what this is, you're fired.
It's the pinwheel.
No.
The propeller?
The propeller. There you go.
All right, right. The pinwheel galaxy and the propeller nebula, right.
There we go.
All right. I'm fired.
And we've had both of them tonight, right? The M101 is the pinwheel, and so now we have the propeller. So nice knots of dark nebulae in this emission region, too. So it really helps define the kind of propeller shape with where the dark molecular clouds overlay where the bright emission nebula is.
And so is it a star forming region as well?
Yes.
Okay.
So,
and is it just a complete fluke that it's got this shape?
Again, I mean, there's so many processes that go on inside one of these nebulae as to where stars are born, where they die, where it gets cooler and denser and you get dark nebulae, or where it stays lighter or less dense, and you hit it with this high intensity radiation from an O-class star and get it to glow brightly like this. And again, trying to rewind it. I mean, what we have here is a snapshot looking at one instance in time of something that's evolved over millions of years. So, to try and piece it back together again, maybe if we can keep taking photos over the next 1,000 years, 10,000 years, then we might be able to get some idea of how to run the picture backwards. There are objects that expand quickly enough that you can kind of do this a little bit with, like the Crab Nebula, which would be a prominent winter object. It's a supernova that exploded that was visible to us about 950 years ago. And so if you photograph it like 20 years ago and compare it with a photograph for now, you can see that it's changed shape and it's changed size over that time due to its expansion. But something like this, it's much slower to evolve, so it's going to take a lot longer to see any kind of changes. So.
Okay, I'm going to move to Cory's photograph, not live view, photograph.
Raw. Again,
raw, again, yeah.
from the dark sky location. This is the Veil, one half of the Veil Nebula.
The veil must be getting pretty low, though, right?
I
It's
was
coming
out.
up. It's coming
I
up.
was out all night for 2 nights in a row, so I got pretty much everything.
Yeah, the Veil's
that
a
I
late
could.
summer object anyway.
Yeah, okay.
Yeah, it's in the eastern part of Cygnus, so
How does I know there's the Eastern Veil and the Western Veil, but I don't remember which one is which. This is the one on the left. If you look at, and I don't know.
left is eastern. Yeah, left would be eastern.
This is,
Okay.
what you're showing is the eastern one, yeah.
Okay, thank you. I have both of them, so.
But yeah, speaking of supernova remnants, I mean, the Veil is a supernova remnant. So a star that died and exploded and then just kind of thrust all this material out away from it. This is some portion of that explosion where it's a little bit thicker. And so you can just kind of see this veil. And I guess this is the Western version that Cory's showing now, the Western
Yeah,
portion
that
of it.
I named wrong, so sorry about that. But yeah, I really liked on this one, even image, I could see.
Yeah, I'm not sure if people can see it over on the right-hand
I'll
side. It
zoom
looks,
in.
yeah, it
You
looks
could actually
so
see like the
wispy.
braided stuff.
Yeah.
Like a braid to me.
Mm-hmm.
And even in it's one exposure raw to the camera, I kind of fell out of my chair when I saw that, and didn't stop the camera until I absolutely had to. So.
Wow.
But this is a 5-minute ISO 800 exposure.
Oh, that's terrific. Okay, I'm going to move to, let's see what Chris is showing us here. So he's showing us, what object is this?
That's the Ring Nebula.
Right,
And
okay,
when
I see. And then you've got different darkness of skies.
Correct. That's what we were talking about, the Bortle scale. The left one is from North Tonawanda, from where I am, and the one on the right is from Cherry Springs, and you can see the difference in the darkness from the ISO.
Oh, yeah.
Yeah, I mean, you're able to drag out so much more detail if you're shooting from someplace dark that, you know, it's otherwise it gets kind of lost and washed away in the light pollution. But, you know, when I was shooting from Death Valley, I guess that was over 2 years ago now, it's unbelievable amount of detail and almost, you know, very little processing to subtract out background at all. I mean, I think I told the nebulosity, okay, go ahead and subtract the background, and it didn't do anything because, you know, it's just so dark out there. So.
All right, I'm going to go to Gary's view.
This is the Gamma Sig Nebula. Yeah. It's almost dead center of the Northern Cross in Cygnus.
You are having crazy good viewing tonight, Gary.
Yeah. Yeah, clear skies.
What is going on? Is it not everything not on fire there right now?
No fire. The moon isn't up.
Yeah. Your seeing is really clear tonight.
So yeah, fire season doesn't. I mean, I think there has been some fire season already, but it usually doesn't kick in hard until September. It's when everything, you know, whatever rains we got over the winter caused stuff to grow. It's all dead by September, and then once it catches. Yeah, just everything kind of smells like smoke around here for about 2 months.
Yeah, no, it happens here too, even. Although we've had a really wet spring, so when we've had, you know, normally I stop cutting my grass by now, but it's still growing like crazy, like a weed. So yeah, it's been a very strange spring. But you know, how do you like your climate change?
No, it's a hoax. It's not changing.
Yeah, that's just gorgeous. Wow.
And I mean,
and you wouldn't see any of this with your none of this with a small telescope even. I mean, you really need the camera.
This requires photography.
Yeah.
Even from the darkest skies, you don't really see the Butterfly Nebula or this complex around Gamma Cygni. But you know, again, just this rich area of star formation. And well, actually, yeah, I'm not even sure how much of this would be star formation. The darker knots in it would be places where stars might be forming. But like from here at our latitude, Los Angeles is 34 degrees north. This passes pretty much directly overhead. It passes within 5 degrees of directly overhead from here. So it's not there now, but by about 1 a.m. tonight, between 1 and 2 a.m. it would be. So.
All right, I'm gonna go to Stuart's view, and just we're starting to run out of time, so just like one more image each, and then we'll wrap this up.
This was actually a mistake. I didn't mean to do this one. I put in the wrong number on my thing. I meant to do M11 and I got M17. I went, wait a second, M11 isn't a nebula, and I looked it up, and this is a Swan Nebula in color. This is a 3-minute exposure, and this is also something I've never imaged before. So it's kind of cool for me.
It's a very pretty mistake.
Yeah. It would be great for you to take that one back and do some processing on it and see what you can pull out of it.
I have to obviously do more and to stack it, but yeah, you're right.
Yeah, I'd say put that one on the menu.
Absolutely.
Yeah. All right, and then Cory. Now Cory's just gone way back into his archive. This you didn't get this from this last weekend, did you?
This is from the past by about 48 hours. This is on July 4th. I saw this. Yeah. I saw M31 start to pop up, and the skies were, horizon to horizon almost, were dark. So I swung the scope over after I was done imaging everything else, and just thought I'd get as much as I could. And I actually ended up getting 45 minutes of good data on M31 before dawn started.
Oh yeah, so it was a total morning object.
It was, yeah. It was. I don't know. I think I started at about 3:30 in the morning and kept it going until it started to turn blue. So, but it turned out really good. I thought this is a 5-minute exposure.
Yeah.
Cory told me that he's planning on assassinating M31 later in the season. This is just something he just wants to absolutely kill.
I will. Destroy it.
You're gonna add it. You're gonna have like its head on your
your
wall.
Yeah. It's supposed to be hard, but I'm gonna make sure that
his field of view is perfect for it, though.
It really is.
He has absolutely the perfect scope for it.
It's even a bigger field of view than Gary's. Not much, but like a little bigger of a field of view. I want this scope. You know how I used to want your scope, Stuart? I don't. I want
his is cheaper.
I know. So that's a big reason why I want his scope.
You can get 2, just in case.
I know. I get 2 for the price of Stuart's scope. Although that mount, I know you dropped some money on that mount.
I love the mount.
Yeah.
Everything goes in the mount. The mount's more important than the scope.
All right. Well, I'm gonna sort of show off what Gary's got here, and then I think we'll start to wrap this up. So, Gary, what is this?
This is a piece of the veil. I think this would be the western.
Yes.
Yep.
Yeah, I show the veil, I show the Cirrus Nebula northwest part, and then the Cirrus Nebula east. So yeah, this is the west section.
That's great. And Bill McLaughlin is watching, so I'm going to say hi to Bill. He wasn't able to join us tonight, but because it's just too bright.
So, Fraser, I just wanted to bring up something that I was shooting earlier today.
Oh yeah.
And the sun, the southern hemisphere of the sun's kind of going crazy right now.
Wow.
And so this is it's called active region 1785, and the Earth could fit from end to end of this thing. You could fit about 6 or 7 Earths from one end of this sunspot group to the other. The Earth is about it's smaller than the size of that largest spot over to the right edge of this. So yeah, so I was imaging this from my driveway earlier today.
We got the request. Wayne wants to know the telescopes that are being used. So why don't we sort of, as we wrap this up, let's sort of have everyone give us the rundown of what their scope is. I'm going to start with Chris. So Chris, what is the telescope that you're using?
I'm using a 6-inch Celestron reflector.
There you go. And thanks for joining us, Chris. We'll get you more technically up to speed for next week.
Yeah.
Cory, what have you got? Oh, this is awesome. So what's your scope? It's the 80.
I'm using an 80 millimeter APO ED, whatever ED APO. I don't think it's a true APO. I think it's kind of a fake one, but it's a ED glass. It's a nice glass for the price. It's a Vixen ED80 telescope. It's the same exact thing as the Orion ED80, so they're all the same glass, just rebranded. Inexpensive, good.
And this image that you're sharing, this is your setup?
Yeah, this was the setup from the 4th of July. This is a single. Oh, what was this? I think it's a 25-second exposure, and
is this with the 14 that we share?
Yes,
Yeah.
This is with the 14, and so that's my little tent that keeps the wind out, and if there's any cars that want to drive by and ruin any exposures, it keeps those headlights off as well.
That's good thinking, which they will.
They will.
Gary, this is your beautiful telescope.
Yep, it is the Celestron 14 Schmitz Cassegrain, and the scope goes from about here to here, and then this front part's a dew shield, and the camera's sitting right inside this shield here. And then this is my guide scope when I take long exposures. That keeps me on what I want to be on. But that's a live view right now, and that's pointed right there at the Veil Nebula.
That's great. Stuart's telescope. I'm trying to remember. It's a 130.
Well, it's a 140. It's
140.
A 140. Yeah, 140. Yeah, 140 APO.
Yep.
Telescope Engineering Corporation. It's kind of their bread and butter, most popular scope, and it's just basically a bigger version of what Cory has.
Yeah. Awesome. All right, and thanks for joining us. And Thad, yours is a 9.5 inch, right?
9 1/4. Yeah.
9 1/4. Yeah.
Celestron Edge HD. So the one thing I've found that's really nice is a lot of times I'll shoot Hyperstar with it, which means I take out the secondary. Putting the secondary back in, I've probably done this 40 or 50 times by now. It's still collimated.
Nice.
So yeah, it's a very well designed scope there from Celestron.
Oh, great. So. And Celestron didn't pay you for that advertisement. In fact, you paid them.
I'm happy enough with it that I'll give them props. So.
Right. Okay, cool. Well, thanks everyone for joining us. Really appreciate it, and sorry for the technical problems we're having. This was keeping me a little distracted for this episode of the Virtual Star Party. But if you enjoyed this, I highly recommend you click subscribe somewhere. If you're watching this over on YouTube, click on subscribe, and that way you'll get notifications when we do other stuff, other live events and things like that. So, yeah, click on subscribe on YouTube, and if you haven't already, circle the Virtual Star Party. And if you click on that, yes, you've attended this event over on Google Plus on the event page, then when we recreate the event, you'll get invited to the next one. So each week you just keep getting re-invited to these star parties, and we get a lot of people want to know, like, how can I find out when the thing's going to happen? You want to get invited to these events, and that way each week you just get the invite. So give that a try. So now we're sort of on hiatus for a lot of stuff that we're doing over the summer. I know Pamela is traveling in Europe right now, and so we're not going to be, that's it for Astronomy Cast until September. I think we'll keep doing the virtual star parties while we've got energy for it, and hopefully we'll start going earlier nights again now that the stupid Earth tilt is moving in our favor again, and we're not going to be so late for the folks on the East Coast. But because I know it's like 1 in the morning right now, 1:30. Yeah,
1:33.
Yeah, the fact that you're watching this, I'm really impressed that you like astronomy that much. So thanks everyone for watching, and we will see you all for the next event. All right. Thanks everyone, and thanks for participating, everyone. And welcome aboard, Chris. It was great to have you join us.
Thank you.
All right, see you later, everybody.
Bye.
Have a
Good night, everybody.
What did I want to do? Okay, all right, it's working. Well, hi everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your virtual star party for July 7th, 2013. The 3 days after Independence Day edition, I guess. So tonight we are going to hook up a bunch of telescopes, and by a bunch I mean two, into a live Google Plus Hangout and show you some stuff that's happening in the night sky right now. Lots of bad weather and lots of sort of busy summer plans for a lot of our people. So it's just going to be just us tonight. So joining us this week, I'm going to sort of start with the telescopes. We've got Gary Gonnella, who's in Los Angeles, and we've got Stuart Foreman, who's in the San Francisco area, so West Coast. And
Hi, everybody.
Stuart is showing us this this globular star cluster right now. And then joining us for sort of additional brain power, we've got Dr. Thad Szabo.
Good evening.
And we've got Cory Schmitz, who is got bad weather, but was going to share some crazy images and regale us with some stories that he just captured a bunch of images. So, all right. So let's just start with this image that we're looking at right now. Stuart, what are we seeing?
This is M13. It's the Great Cluster in Hercules. This is a 60-second
But yeah, I mean, essentially, a globular cluster isn't really the place you want to do that, though. The stars are old, and they don't tend to be very metal-rich. And one thing that we know is necessary for at least life here on Earth is having this abundance of elements heavier than helium. If you have a bunch of old stars, like in a globular cluster, it's going to be mostly just hydrogen and helium that make up the stars. Now, some of them die. It could possibly create some carbon and oxygen, but you won't have quite the rich array of elements that would be typical in, say, the part of the galaxy where our sun resides.
So just to let people know, you can comment, you can talk to us, as it were. You can make any requests if you want. If you know some objects that are up in the night sky, usually we have some new objects that we never even occurred to us to look at when people make requests. So it's awesome. So the ways that you can do that, you can make a comment over on the event page if you're watching this on Google Plus, or in my stream if you're watching this that way, or you can make a comment over on YouTube. You can also use Twitter, although it doesn't seem to be working very well. So the safest place, we always say, is over on YouTube. So if you're watching this, anywhere, just click on it to watch it on YouTube, and then you can make your comment there. Yeah. So I'm going to move on to the object that Gary is showing now. Chris, can you hear us? No, this is Chris. Chris is going to join us. He's got his telescope too, but he's having some technical problems.
If you look closely, for instance, at the Hubble pictures, you can see inside you'll see a pillar, and then you'll see a little protuberance off of one side of it. At the end of that protuberance is where a star is forming. Once fusion kicks in, it kind of is able to shed that dust away then. So yeah, I mean, the variety of possible initial conditions in a star-forming region like this, you can get all kinds of weird shapes going on. So, yeah, to try and rewind time and figure out, well, how exactly did it get this shape? That's an extremely difficult problem to try to do computationally, and especially from observations, because essentially, I mean, it's very hard to get any kind of 3D feel here. You get the idea of, okay, well, there's this dark gas standing out against this bright background, so I mean, it's a little bit of a 3D feel. But I mean, anything that you do in space where you're trying to image something and also get a feel for the distance is very difficult to do. So yeah, trying to rewind, okay, well, how did it end up looking this way instead of like a smiley face or whatever else? That's a non-trivial, almost a not possible problem at this point. So
now I'm hearing some reports, and I'm actually sort of able to confirm this. I guess I'll have to click on me for a second here. That nobody is able to see the film
exposure at ISO 800 with a Canon XSI camera, and this is non-cropped, slightly stretched and noise reduction, but this is sort of as you see it in the camera.
So,
oh, go ahead.
Okay, yeah. So I mean, globular clusters are essentially left over from when the galaxy formed, meaning that the stars that are in there are about 13 billion years old. This is the second largest one that's visible to us with that accompanies our own galaxy, and the largest one easily visible from the northern hemisphere. And if you look at kind of SETI activities, there was a signal that was sent at this globular cluster as from the Arecibo radio dish in an attempt to say, to try and make contact. I'm not sure that was the wisest target, because it's very unlikely that there's any life there. But that's where they sent it.
So they tried to send communications out to try and make contact with folks in the cluster.
Yeah, there was right. They kind of fired a burst, and I forget what exactly was in the message. I mean, we could possibly ask Sandy, I guess, next
right.
hangout, but weekly space hangout.
So we'll see if he's able to hear us, and if not, then he will watch us. So, Gary, what have we got?
We have M16, the Eagle Nebula, and this is a 60-second exposure with no binning. So I can.
You know what we want to see, Gary? Like just make it happen.
You want to see the pillars of creation.
We do.
And this is 60 seconds, and there it is right there.
Nice.
That's the famous Hubble part. There's the whole picture, so that's right in this area here.
Looks about the same, I think.
Is Hubble?
Yeah, it's about the same as Hubble. A little better, I think.
Mine's got better color.
Yeah, but I might be remembering it wrong.
Yeah, you never know.
But I always wonder, the pillars are such a strange shape. They look like a rocket kind of blasting off through this nebula. What's really going on there, Thad?
Well, I mean, any time that you have material that's kind of collapsing under gravity, you also have shock waves that have gone through here repeatedly from nearby supernovae going off. So the shape. If you look across most nebulae, you're going to see some kind of twisted forms in here. The pillars, again, if